Good day, and welcome to our webcast, Current Issues in Industrial Analytics, brought to you by CFE Media and Technology and sponsored by Epicor. We're joined today by Michael Malone, Principal Process Engineer, Toray Plastics America, and Blake Griffin, a Senior Analyst, Interact Analysis. I'm Kevin Parker, an editor with CFE Media. Industrial analytics are used to identify machine behavior patterns, make fast, accurate predictions, and empower confident decision-making. In this webcast, we'll review a predictive quality and process optimization use case involving the plastic fabrication company, Toray Plastics. Mike Malone's streamlined access to blending component data contextualized with process data. Using IIoT sensors and industrial analytics, Toray monitors film temperatures, polymer pressures, and machine feeds. Visualizations and alerts make digesting the resulting information intuitive. To date, only a small percentage of industrial companies incorporate machine data in their analytics processes for decision support and intelligent operations. That's bound to change, says Senior Analyst Blake Griffin of Interact Analysis. In our second presentation, Blake will review market and technology trends related to predictive maintenance, especially when it comes to motor-driven systems and rotating equipment. Here are some tips to help you get the most from today's webcast. If you experience issues with the slides or audio, refresh the browser or click the Refresh Media button under the presenter's picture. Control the volume of this webcast by adjusting your computer or the webcast platform. For technical problems with the audio or slides, click on the question mark at the top right-hand corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. The Ask a Question box is also used to ask the speakers questions. The live Q&A session will begin after the presentations concludes. Today's webcast is being recorded. You will receive an email within a week with a link to the on-demand event. We'd now like to share with you a brief video from today's webcast sponsor, Epicor.
Manufacturers are facing a barrage of information about how new disruptive technologies will change the face of their industry. But for manufacturers to embrace mobile, social, analytics, cloud, and Industry 4.0, they must have a clear understanding of the technology value add within the context of today's business environment. With all this talk about Industry 4.0 and data deluge from all the interconnected devices on the factory floor and analysis in the back office, manufacturers may wonder, where does ERP fit into this new digital frontier? The reality is that ERP is more relevant in this equation than ever before, and manufacturers need the ability to contextualize data and integrate it into downstream process flows. To do this, ERP systems must be reimagined to meet the needs of new and emerging manufacturing technologies. Responsiveness demands simplicity and mobility, with tools designed to meet the specific needs of specific users. With an ERP system that delivers this, manufacturers can check off a big box on their Industry 4.0 readiness checklist and make good on the promise of real-time, actionable intelligence.
Welcome back. I'd now like to introduce today's speakers, Blake Griffin and Mike Malone. Blake Griffin is a senior market analyst at Interact Analysis, where he has conducted research into markets pertaining to factory automation since 2017. Blake has conducted more than 75 hours of interviews with technology suppliers and users and produced dedicated research studies on the topic of predictive maintenance and its related technology. But first, we'll hear from Mike Malone. Mike graduated from Worcester Polytechnic Institute in 1995 with a degree in mechanical engineering and started his process engineering career at Toray Plastics just a few weeks later. He's been improving rate and yield while reducing waste and costs for the company ever since. Mike, the floor is yours.
Thank you, Kevin, for the warm introduction, and welcome everybody. Thank you for attending the webcast. So as Kevin said, I've pretty much right out of college, went right into process engineering, Toray Plastics in North Kingstown, Rhode Island, and really got in on the ground floor of what we now consider computerized digital self-service analytics. In general, it's really been in the last decade, where we started to bring in a process data historian, started to invest more in IoT sensors to get more process monitoring. And then a big leap ahead was when we started working with TrendMiner in 2018 to really get the on-demand self-service analytics, upfront, on dashboards and with our process engineers, and really be able to have better process control, improve uprate, and yield. So as we talk about Toray's analytics journey, it's really my journey too. And so although today we'll focus primarily on a couple of projects that we're working on right now, which are far more advanced from where we began. When I started, basically a lot of data was collected on paper. We would record values from a digital control system, but even though it was a computer, it wasn't connected to anything. So that's one of the main advantages of the current self-service analytics, is that all the data is coming together in one common place, and then anybody can access it. So we're talking, I used to deal with paper chart recorders. There's just so many ways to lose focus or to lose key bits of information, and trying to go back and understand what happened in the past was really a big challenge, very time consuming. So, it's leaps and bounds ahead in the last, certainly over the last 5 years. And as I think Blake will get into, what the future is really bright in terms of data, on-demand data analytics. So before we start getting into the presentation, I'll talk a little bit more about my company. I work for Toray Industries, but Toray Industries is a truly global corporation with companies in 29 countries. Mine is Toray Plastics America in North Kingstown, Rhode Island, and we work primarily in the manufacturing of thin polyester sheet films. Toray is also a world leader in synthetic and carbon fibers, and it represents 41% of performance chemicals produced. Here is a aerial view of our pretty substantial manufacturing campus in North Kingstown, Rhode Island. We have 6 manufacturing lines in-house, and it's really been an excellent place for me to work, since the start of my. So talking about the agenda, I'm introducing myself now, but when we get into the specific use cases, we'll first be looking at where we saw a little bit of a blind spot in terms of evaluating process data at uprate, when we would really need on-demand access of raw materials, and having to go and track that down in separate systems, wasn't that efficient. So what we worked with TrendMiner and Context Hub is bringing all of that contextual information from raw materials directly into the trend viewing and analysis locations. With the investment in IoT sensors over the last 10 years or so, we have a lot more monitoring capability that's not directly linked into any process control. So it's very helpful for this information that is pulled from historian to be viewed live in dashboards that allow operators and process engineers to understand, whether it's a go or no go for good quality, or a risk of a line upset. So the products that I'm talking about that we manufacture are being displayed here in this slide. And one thing of note, and I would like to always say this when we talk about when I talk about getting in on the ground floor, is when I first started Toray Plastics, the primary product was, believe it or not, was base film for VHS video cassette. And I'm sure most of you in the audience, are familiar with what a VHS tape might be, but whether you've actually seen one. So Toray's really reinvented itself in North Kingstown with a lot of investment from Japan, and now our product line is world class, and it's a testament to the company as a whole. So this has been my playground. This is the film process, and in a very schematic view here, when we start with raw materials, which then are mixed together and dried. So it's pellets and resin chips, the polyester, and some recycled ground-up film. That material is then extruded and cast onto a chill drum, making an amorphous, we call it A-film sheet. And then it goes into an MD stretching process where the film is elongated in the machine direction. And then the film is then cooled and then reheated and stretched in a transverse direction in the center of the TD stretching and heat set. And this is a key point of the process, that the investment in IoT sensors has been huge in the last 10 years. When I started, and for the first decade or so, if we needed to know what the temperature of the film was passing through the TD stretching machine, we had to physically go in and measure it with an IR gun, which can be done safely, but is not the most fun task that you could do. But it's very important to know what the film temperature is. So that was a blind spot, not knowing in real time what the film temperature is. So we have since invested in some high quality temperatures, IoT sensors in there. So now no one has to go into the oven anymore to get the film temperature. We see it live on dashboards. We know what's normal. We know what's not. And having upsets related to improper film temperature is really a thing of the past. And then the process then ends with a winding process. We make some master roll, and then that each mill roll in itself is like a batch, but line itself runs continuously. So one roll finishes and another one immediately starts winding, and then those rolls are converted into the correct width for the customer. Improving manufacturing quality and upgrade with big data and on-demand analytics. So the first use case to talk about today is bringing raw materials directly into the trend viewer, in data analytics. So it's very common as a process engineer when there's a line upset, and when we're looking at trend data, and in this particular slide, this is from our extrusion process. One of the first questions that we're asking is, what raw materials, did we change, recycle? Did we add more of component X or Y? And it's not readily available. So in order to find that out, we will go into our plan app system. We have to reference two different tables, one for the individual scaling of the batch, and then a second one to see timing-wise, when it got into the process in terms of the start of extrusion or the end of extrusion. So this is a little somewhat inefficient. So the problem statement was, okay, well, how do we contextualize this, more readily with the process data that we're getting back in self-service analytics? And the answer to that was to have the self-service analytics program talk directly with plan apps and query this information automatically on a batch-by-batch basis. So in this trend, the top line that's a straight line, each of those little information bubbles represents the beginning / end of a batch. So whenever I'm viewing process data and I see some trending up or trending down, I can immediately understand, what material we're using at any given time. And that's kind of a jumping off point for investigating what might be causing a material loss or some down. With all of this information coming in, we're basically combining two data tables into one. So it's very easy to jump between the trend viewer and into this context hub view, where we have a data table that's very easily sortable to understand, batch by batch, what components are in or what components have been pulled in. Another tool that is also very helpful in understanding contextually with the process data is a Gantt chart of a timeline view. So I very quickly can, in this case, there's a component called ERN81. When did we start using that? It's very easy to see. And then from that, I can directly click and launch directly into a process data viewer and then perform analytics from that point. In this particular case here, you can see that the speed, the machine speed was somewhat stabilized, but the pressure was not. And so it's a jumping off point, and then as opposed to guessing what was going on. So streamlining process monitoring and the self-service analytics. I mean, a lot of what we've been able to do in the last couple of years is develop dashboarding, where the information coming in from the historian can be displayed quickly, with some key performance indicators. You can set control ranges. So in this particular view, we can see a couple of the process values for temperature or pressure are in the red. So that's alerting the operator engineer that something's not right. Now, as a disclaimer, in terms of anyone trying to learn how to make polyester film, so these values are the token values, that they don't mean anything specifically. Just a disclaimer there. Also in these dash hubs, the raw material component is also directly accessible, so that anytime I'm there, I can click right into the take a deeper dive into the trend analytics, without having to build my own trend. I mean, it's ready to go. And then if I wanted to look at raw materials, I mean, that's also directly available from these dashboards as well. And I foresee, as this becomes more and more commonplace, we'll be adding more sensors in the process and becoming even more robust for quality control and upgrade purposes. So that was my final slide. So now I'm going to transition over to Blake.
There I am. Thank you so much, Mike. I really appreciate you passing the mic over to me. It was a very interesting presentation. I really appreciate that CFE organized the presentation this way, because I think you get a really good example of a case study, actually utilizing this technology, on the front lines with Mike. And I'm coming at it from a somewhat different viewpoint. So I am a senior analyst at Interact Analysis, where my job fundamentally is to go and interview suppliers and users of technology to understand the trends behind it, and from a market standpoint, where the technology is headed. So I'm going to give more of sort of a bird's eye view to contextualize what Mike just presented on. So before I go into the data, I just wanted to give one quick viewpoint on how exactly we measured this market. As you can imagine, predictive maintenance is a very complicated topic to begin with. So measuring, getting some sort of sense for how big this market is from a revenue standpoint, from a unit standpoint, is incredibly difficult, because you don't really know where to draw the line in the sand. So what we tried to do with this research was pick some products that represent both the future of predictive maintenance and motor-driven systems, as well as some of the legacy equipment that's used to perform predictive maintenance. So the only area of this slide I want to bring attention to is the top left, this primary product analysis, because there will be some data that I'm presenting that shows the forecast for this technology. Smart sensors was really the core product that we wanted to talk to suppliers of and measure to get a sense for how this is growing. The reason for that is we view smart sensors as being a technology of the future, and I'll get into exactly what smart sensors are in a bit. We also measured the size of the market for gateways used in this application. Portable measurement devices. So if you're familiar with performing this sort of maintenance, a portable measurement device would be a vibration, like a handheld vibration monitor, or anything that you can actually bring to the equipment and get really detailed data on whatever process is happening. That kind of represents the legacy. I'll go into where I think that technology is going as well. And then lastly, so traditional sensors we didn't measure because, again, it's very hard to draw a line in the sand on where sensors are being used for predictive maintenance versus just some other purpose for the process. But we did try and address it qualitatively and how it fits into the overall solution. The last two areas that we looked at, dedicated software and dedicated services. Again, very, very difficult to draw a line in the sand of what software and services are for predictive maintenance. For instance, like you can use very sophisticated data analysis softwares that are more general purpose in nature, and you could theoretically pump any data you wanted into it and derive some analysis. However, if we would have included revenues associated with those softwares, it would have bloated the market size tremendously. So when we say dedicated, we're really referring to software and services and gateways used specifically for the predictive maintenance application. So that's fundamentally what makes up any sort of revenue or unit size that I mentioned. It's those products that I'm talking about. So yeah, with that, let's jump right into it. The first thing I want to show is a spectrum of maintenance strategies. So I think if you are involved in maintenance at any level, or if you're an engineer walking the floor, you'll be sort of familiar and you'll be able to plot yourself on where you fit on this spectrum. It's a spectrum of sophistication, if I'd say that correctly. On the far left, run to fail would be sort of anything that isn't process critical. Maybe it's a motor that's really inexpensive, or perhaps it's a motor that you have a lot of backups and inventory that you can just hot swap out, something that's not going to be very expensive if it goes down. This is not a great strategy. I think it goes without saying, but it does have its place in some areas of a facility. As you move, further to the right, you hit preventative maintenance. And I really want to harp on this because in my conversations with suppliers and with users, preventative and predictive maintenance get confused all the time. And I think it's really important for you as engineers to make sure whenever you're talking with stakeholders that you're using the terminology correctly, because they carry very, very different meanings in terms of the technologies used and the scale at which they can be deployed. So preventative is really doing, and we define it as doing kind of the bare minimum recommendations for keeping your machines up and running. So it could be regular oil changes, anything that's going to keep your line running that's recommended by the manufacturer. So I'm like big into mountain biking. This would be like regularly lubing like my chain, getting it tuned up every 6 months or whatever, just so I ensure that when I'm in the backcountry, my chain doesn't break or something doesn't go wrong. I'm not stranded out there. Same with the manufacturing facility. It's doing the bare minimum to prevent downtime. As we move further to the right, we get into what's considered condition-based monitoring. This really gets gets into a gray area between condition-based monitoring and predictive maintenance. Both are fundamentally using the same technology, but the analysis that's performed is slightly different. Condition-based is really looking at how machinery is performing in the current state. So whenever that measurement is taking place, what is the status of that machine? So perhaps the motor would be considered under stress. You can kind of think of it as like a stoplight, which I've seen a lot of actual products incorporate this kind of stoplight functionality. So it could have green. If it's showing green, everything's fine and dandy. If it's showing yellow, it might be trending towards something else, maybe trending towards failure. Red might be like red alert, you need to service this immediately. So it's giving that perspective of whether or not a piece of equipment is at risk, but it's not necessarily putting a timestamp on when that actual piece of machinery will fail. So there's a couple, I'll go on the bottom of this spectrum and just give you some idea for where some of these lie, these kind of sub-strategies. So there's route-based maintenance, which is going around and actually taking measurements from a smart device, or this again comes into the portable measurement devices. You can have someone walking the floor and taking measurements. That's obviously limiting in terms of the amount of measurements that can be taken. But I will say the portable measurement devices tend to be very sophisticated in terms of the data that they can produce. So a lot of times you're gaining a lot of resolution by by using those types of measurements, or excuse me, using those types of devices to measure the health. As you move further towards predictive, I have this parameterization by skilled maintenance tech. I'll hit on this a little bit, but one of the core things that I believe is crucial to predictive maintenance being successful is having the subject matter expertise at hand. We were talking before this call and just discussing like the subject matter expertise isn't going anywhere, and I think we all agreed on that. If you look at data science as a discipline, subject matter expertise is one of the things that's required. Even if you're developing, really sophisticated machine learning algorithms, you need to have someone in the room that knows the application and can help train that algorithm based on how the machine's supposed to behave. And really, unless you have that expertise, it's very hard to do that. So I put that in the more sophisticated category, inching towards predictive. We get into the physics of failure and monitoring with the historian and the machine learning strategies. All of these are what I would consider predictive. Physics of failure works really, really well in well understood applications. So if you're talking a pump or a fan or something that runs in a steady state that has a really predictable vibration pattern or temperature that's supposed to operate in, this is something that you can employ physics of failure, meaning if it falls out of this, this known quantity, you can kind of trend over time when it's likely to fail. Monitoring with a historian it's a little bit more sophisticated. This is what Mike was hitting on, pulling data from the historian and trying to make sense of that data and trend that data over time to try and come up with some useful insights that you can use to predict when your equipment's at risk of failure. And then lastly, AI and machine learning. This is the future. I mean, there are some machine learning algorithms out there that are very effective. I think we're a ways off, if I'm being honest, from machine learning being something that can be broadly applicable. But like I said, in well understood applications, this is absolutely being deployed and can be effective. This is what I would consider the most sophisticated, especially as the technology improves. And we can start using it in more broadly in different applications. It's going to be what I think people strive to produce in their facilities. So as I was saying, smart sensors I think are some of the products on the market today that are going to represent the future of predictive maintenance, and I'll go into why I think that is. So first, let's define smart sensors. They're wireless, capacitive, MEMS, or piezoelectric-based sensors, which can communicate asset health-related data. So it's usually vibration and temperature. That's pretty ubiquitous across all sensors, all the smart sensors out there, to an edge computer or subsequently the cloud or a smart device, wherever you want that data to go. I consider this a frontline technology, and what I mean by that is the data that it can provide, the resolution is useful for flagging when things are at risk or when it's trending in a certain direction. But in order to actually diagnose an issue, smart sensors aren't really there yet in terms of being able to get to that level of analysis. But it's still very, very helpful. It's using a combination of smart sensors and portable measurement devices. You can have a really sophisticated solution for eliminating downtime. It's an enabling technology for automation suppliers. So one of the things that you'll see is many of the big industrial automation vendors, so Siemens, ABB, Rockwell. I don't know if Rockwell actually produces their own sensor yet, but ABB and Siemens certainly do. They're producing a sensor, and it really enables more assets that were offline before to be online. And that in and of itself is very valuable to an automation supplier because they can sell software and services alongside that. Some of the barriers to adoption the barriers to adoption are decreasing right now. So why I think this is such an important product to monitor is the cost is decreasing substantially. It used to be pretty prohibitively expensive to put together a full-scale predictive maintenance solution that you can deploy broadly across your facility. The cost of these sensors and the software that come with it, I think some of them are priced at about $100 a sensor per year or something like that. There's different models, but that tends to be a common one. My point in saying that is you can deploy these on areas where you know that you have problems in your line, and you can kind of do it on a case-by-case basis. You don't necessarily have to wire up your whole facility to get immediate ROI on this technology. And the cost is continuing to come down. So I think as it comes down even further, the barrier to adoption is lowering also. The battery life is also improving, which is really, really important. Because as the battery life improves, you don't have to go out and service these as often. They become a more reliable solution. And there's an increasing ability to interrogate data. So I mentioned that we don't necessarily consider general purpose software in this, but we are seeing more and more that be used to interrogate this data. One other thing that I like to mention, so I've had conversations with a lot of machine builders that they have kind of discovered this hole in the market, if you will. They, if you think of a machine builder, some of the machines are very nuanced and not necessarily well understood from a data perspective. What they've discovered is that they are the experts on their machine, and if they can develop some sort of algorithm or software some sort of algorithm or software that they can write and design to use and to sell to other people using their machine or using similar machines, they can actually develop a new product for themselves. And that's starting to occur, basically a miniature app being developed and sold sometimes on Siemens MindSphere or other platforms of the like. So moving on to some of the top barriers. One of the top barriers, I think, goes without saying, is this data access and ownership concern. Opening up operating technology is always a concern for people involved on the factory floor. This is still a major concern, I think a major barrier to the adoption of predictive maintenance tech. It doesn't help that we've had a lot of cybersecurity issues cybersecurity like major news stories in the last couple of weeks. And I think that will continue to be an issue as we progress. Fortunately, you don't have to connect to a network necessarily, or you don't have to connect to like an outside network in order to produce predictive maintenance. There are a lot of suppliers out there that are offering on-site solutions. There is a bit of a trade-off there, because if you're using an on-site solution, you're really relying on your factory only, and it takes a little bit longer to train the algorithm in those solutions, as opposed to having multiple people using the same algorithm and having more data to draw from. But it's something worth noting that there is an ability to use it offline also. Access to connectivity is a big issue, and this is not only like connectivity to internet, but there's actually access to the physical machines that to wire them up. This is something that it's kind of silly seeming, but a lot of the equipment that's very process critical is hard to access. So it's very hard to wire them up. That's a bit of a softer barrier than the first one, but it is something that people have noted to me over the last couple of years as I've been doing this research. There's an established status quo of maintenance methods. This is sort of the human aspect. There's a lot of maintenance techs out there that are a little, I would say, shy of diving into this tech, either for fear of perhaps their job is being threatened or something like that. I think over time, like, this is going to be an inevitability that this tech will be used, and developing your skill set around this tech earlier than later is worthwhile. And a lot of a lot of the driving force behind adopting this tech is coming from the top. So getting familiar with it, I think, is worthwhile. And I think that barrier will fall over time. The need for a proof of concept is also a bit of the human aspect. I think there's a tendency amongst engineers and amongst manufacturing in general that it's difficult to enact change in a facility because whoever is leading that charge, if something were to go wrong, I mean, it could potentially open up risk for a line going down. So not a lot of people want to necessarily take that leap. This is, again, like the human aspect. I think as the technology becomes more proven, this barrier will come down over time as well. But it is, I mean, manufacturing tends to be a very conservative industry. So I think it's going to take a while to get there. And we'll get in the next slide on how fast I think it's approaching. And then the last thing I don't have to go into as much because we just talked about it, but it's perceived as expensive. But as I said earlier, it's rapidly changing. Let's go to exactly our forecast for this. So my takeaway, or the takeaway that I want you to have with this graph, is that it's a very small market right now. So the way we've defined it, looking at smart sensors in particular, it's extremely small right now. So if you look at the dark blue bar in 2019, which is when we gathered data, it's far less than $100 million in revenue. But when I was talking to suppliers, I was hearing revenue growth numbers of double, triple, and quadruple regularly. That was the normal rate of growth that people were experiencing. Anytime I hear that, it's generally a sign of an inflection point or kind of entering the exponential growth phase. So I expect that this market is going to take off in favor of smart sensors over the next 5 years in our forecast, but well into the next decade. As you can see, the portable measurement devices, which is represented by the gray bar, is not decreasing. It's growing actually by about 10% over the course of our forecast. Again, I think this is a product that is needed in order to have like a well-rounded solution for predictive maintenance. The resolution that it brings you, and also the person that's behind the portable measurement device that has the subject matter expertise, both I think are needed in order to really get a handle on your equipment and the health of any asset that you're monitoring. Over the course of our forecast, again, we think the market's going to be more heavily software driven, and well beyond our forecast, we think it's going to be almost entirely software driven. Obviously, the portable measurement devices aren't going anywhere, but we actually view smart sensors as eventually being given away for free. I always compare it to, if you're familiar with Square, so it's the point of sale system that's used at like coffee shops and food trucks and whatnot. Their whole model is built around giving away the card reader for free and then selling their software. And I think a similar model is going to be enacted with smart sensors and a turnkey predictive maintenance solution as the cost of the sensors come down to a negligible point. Backing up a little bit, I know I got ahead of myself on this slide. There are really two approaches to predictive maintenance: a software-based approach and a sensor-based approach. Software-based is similar to what Mike was talking about. He's obviously using sensors as well, but gathering data from a historian or from other devices that are already deployed. This is used pretty heavily and has been for, I guess, as long as predictive maintenance has been around. But this data is only as good as the devices that are producing it. So if you have a lot of legacy devices in your line, it's going to impact the quality of insight that you can derive from it. There's a sensor-based approach as well. So this is it's a combination of sensors and software, because you can't have sensors without the software to analyze, or at least it's not useful. But this is more the smart sensor approach. So if you wanted to, drop, I don't know, $5K on sensors and software to wire up your most process critical, you can do that with a sensor-based approach. A greater variety of companies are starting to enter this market. So one of the companies that I've observed starting to catch on that they might be a good solution for bringing data under one umbrella are CMMS providers. So CMMS, if you're unfamiliar, is a computerized maintenance management system. I may have gotten my M's confused there, but you get the point. They are starting to offer services which aggregate data from a lot of different areas of a factory under one roof, which I think is really helpful, because whenever you start censoring up areas of a factory, there is a tendency to get data silos across your floor. Any sort of solution that helps to bring that data under one roof is very helpful. So CMMS is one group that I've observed starting to offer this, but there are others as well that are offering products specifically for that purpose. I think that is it for this one. I jumped around a little bit, which is why I'm a little disoriented, but let's go on. So this is my last slide. There's some considerations for the future. I hope by now you kind of have a feel for where this market is headed from my perspective, and hopefully it's helpful to understand so you can start preparing for the future. But Some considerations. So we expect an increasing presence of third-party maintenance providers offering remote monitoring, predictive maintenance services. The reason that we expect this to occur, smart sensors are very helpful, especially when used in to do remote monitoring for third-party maintenance providers. They can start offering more services because they're not geographically bound. They don't have to go do route-based maintenance at all these facilities. There's an increasing presence of business models pricing on a factor of uptime as opposed to pricing of the whole machine or component outright. This tends to be a marketing term that you hear all the time, but as a service models, that's effectively what we're talking about here. It's the idea that a company retains ownership of a machine and can lease that machine out as a monthly expenditure. So converting capital expenditures to an operating expenditure. It's a very difficult business model to navigate. But one thing that predictive maintenance helps with is it helps the company that's supplying this machine or whatever it is extend the life of their machine and offer services around it. So we're starting to see that pop up, the machine as a service model, but also some components of it as a service as well. There's an increasing melding of software models and smart sensor models. Again, this is what I was talking about earlier. So there's two methods of producing or conducting predictive maintenance. The software model being diving into a historian or using devices around your facility. And this kind of gets into the next point as well. And smart sensors, which are what we talked about earlier, which is easy to deploy, kind of a turnkey solution offered by a lot of companies. More and more manufacturers are starting to use both methods as a mechanism for having more data on their process. And I think that's going to continue, and eventually there will be some acquisitions in the market where there's a solution for both sides. There's an increasing use of automation equipment to supply greater data resolution. The example I always give here, so I cover the motor drive market as well. And there's a drive by Danfoss. I forget the name off the top of my head. It's the automation drive, but I can't remember the model number. The drive is really interesting because they're trying to push a drive as a sensor. That's the term that they use. And it effectively reads the current draw of a motor to predict when it's under stress, but it also can aggregate data from sensors, which I think is really interesting because it's kind of taking advantage of two trends that's used to promote more data about your process. So more and more, I think that feature will become standard in the drive market. It's going to take some time. It's obviously a future trend. We're not there yet, but sort of like automatic car windows in the 1970s, that was like a rare thing. But now, I mean, you wouldn't buy a car without automatic car windows anywhere unless you're like renting a U-Haul or something. That's kind of how we've pictured it for the drive market also. Right now, it's a premium trend, but over time, it's going to become more standard. And that goes for other devices in the field as well. And then lastly, this is something just thought for the future. As efficiency regulations ramp up on motors and any sort of rotating equipment, and they continue to get more and more strict, we expect sensing components to be actually integrated within some of this equipment. I think this is far beyond the forecast of our report, but it's just some food for thought. I think one of the helpful things with sensing any sort of rotating equipment is that, yes, it helps with predictive maintenance, but it also helps get you a sense for how much energy you're using in different applications. And I think this is something that a lot of the regulatory bodies will latch onto. So expect more integration of sensing components and some of the rotating equipment as well. That's the last of my ramble on predictive maintenance. So I hope you guys enjoyed it, and I'm going to pass it back to Kevin now. Thank you so much.
Well, thanks, Blake. I thought that was really interesting. You made a number of, I would say, nuanced observations about how this market is evolving. And, I covered the enterprise resources planning market for a number of years, and that market started out with SAP, the first MRP system, and over a period of years, there were globally well over 300 ERP vendors before the whole thing kind of collapsed into leaving about a dozen. So I assume that when you talk about industrial analytics on the one hand, or predictive maintenance on the other, that you see those two markets still in the growth path. Can you give us any kind of number about how many predictive maintenance suppliers you're looking at, or even more industrial analytics?
Yeah, it's tricky because so we didn't do a competitive analysis for this particular report. We usually do for most of ours, but the way that we define the market, it was such a young market that there were so many like new companies popping up every couple of weeks that it would be difficult to produce any sort of relevant data on them. In the way that we define it, so there's a number of smart sensor companies out there that produce kind of a turnkey solution, like I was saying, where you can have smart sensors in the software along with it and deploy it very easily. There's a whole other array of companies out there. I mentioned the big industrial automation suppliers that produce the software side of things, and they also produce some smart sensors as well. So I think that you have a healthy mix of startups doing very innovative stuff. You have a lot of big industrial companies also doing innovative stuff. But there's a big mix of people entering this market and trying to offer services and softwares around it. I hope that answers your question. I didn't have a specific number, but in short, a lot.
Well, I think that answers it certainly. Mike, I want to circle back and talk a little bit about your very interesting implementation. From your own point of view, what was the most challenging aspect of the project from start to finish for you?
Thinking back, I think what we realized in terms of how much information that we wanted to bring in contextually for the raw materials is that it was really more than what would actually become usable. So it was a matter of really focusing on like what would be most important to the user. I mean, so I think in the beginning, paring that down was and getting the right decision on what's going to have the most impact to be viewed contextually with the trend viewer, and not overwhelm the user with too much information that might be confusing.
Right. I mean, it's very interesting. We could carry on this conversation about subject matter expert versus data scientist ad infinitum. But I know that the software that you're using on this project is one of two systems that kind of label themselves as self-service, which the implication being that the engineer could come in and gain enough understanding so that he was able to make progress on his own. Talk a little bit about that as to how you see the average engineer being suitable or not suitable, or is there a point where they're definitely going to need help, or it varies depending? A little vague there, but please go ahead.
I think in a nutshell, it makes it a lot from a training aspect in terms of a new engineer coming in and learning the process and beginning investigations into process upsets. Having all of these more advanced analytic tools is very helpful. So I think for myself and training somebody new, I think this is a huge benefit. So it benefits both sides, both the teacher and the student. And a lot of this is very intuitive. And there are still some tasks that we may still do a different way that that takes more time. So we're constantly thinking about, well, how can we integrate this in and improve it, because we've made such a big advancement with what we've done with TrendMiner so far. So yeah, I don't think we're starting a little by little. I mean, at the operator level, I mean, there's some operators that have a good technical acumen on their own and it can get value out of self-service analytics as well, particularly in the dashboarding and stuff. So I look forward to moving that ahead. But before this data analytics explosion and digitally over the last 10 years, it was pretty much just the process engineer. Now people with less of a background can jump in much more quickly with the tools that we have now.
What do you think about that, Blake? I mean, I've interviewed some of these analytics companies, and it's kind of a stock question. but it's funny how they come up with different answers. That they've got a methodology that to extract the information out of the subject matter expert and put it in the machine, and or we have a way of extracting the data, and we really don't need to know that much about it. Along that range of starting with self-service to buying a service that does it for you, where does that tend to go? Yeah,
it's a good question. So it goes back, I think, to what I was saying earlier, which is there's, in my opinion right now, the amount of applications out there that you can use this technology on is so broad that it's almost oversimplifying it to say that you can have one solution that fits all. Like I was saying, there is this idea of physics of failure, which I was talking about, which works well in really well understood applications. And you can incorporate subject matter expertise on certain applications, but for a solution to be accurate and be able to forecast effectively for all applications, I think that is sort of pie in the sky right now. I think what's more likely is that you'll have it on a case-by-case basis of some companies specializing in specific applications and developing solutions with their subject matter expertise, and developing really, really effective solutions, similar to like what Mike has done with their plastics process. Having subject matter expertise on specific machines and specific equipment is still very, very crucial. I think further to this, and sorry if I'm going on a little too long, if there are simple applications like pumping applications that are general purpose in nature, that have that sort of scale, that's somewhere that I could see a solution being offered that whatever points you were making, where they could develop some sort of robust algorithm to address most failures in that solution. I think that would be reasonable, but for really nuanced applications, it's difficult to develop something that's effective and applied broadly.
Good, thanks, Blake. Mike, we asked you what the most challenging aspect of the project was. What was the most rewarding aspect of it from your point of view? I
think once we had the project completed, it was most rewarding to see the engineers using the new tools. Getting the answers in terms of raw material context and stuff in practice. So it went from conceptually that there's a better way to do this, and then seeing it used in practice is definitely rewarding.
And have you guys got in mind follow-on projects that are going to enable you to continue to develop your practice in analytics?
Yeah, I mean, there's I think I alluded to this in our pre discussion before we went live, that in terms of predictive analytics and stuff, I mean, what we find sometimes, even though we're collecting a lot of data, there's still some blind spots. So I think finding out what those are and then justifying further investment, because obviously nothing it's not free. So we have to justify that if we were to monitor airflow at this particular location, that cost X amount of dollars, things like that. And then that would become part of the overall big data historian. But I think the visualization with dashboarding and making it so much easier to put a visual picture of the health of the line out in front of as many eyes as possible. So that I think that's what we'll continue to do. Try to fill in the blind spots, but to have more closer to 100% of full data analytics for the entire process, and then grow the visibility of the tools, not only within the technical engineering department, but at the operator level as well.
Well, thanks, Mike, and I want to say congratulations to you and to Toray on what is really an interesting and exciting implementation of an advanced technology. Blake, let's talk for just another minute more that we have left. And I was wondering, the idea of, when I first heard that advanced analytics was going to be applied extensively to rotating equipment, I thought, well, I guess. But then I was talking to someone from OSIsoft, and they said, well, you have to understand, midstream oil and gas is about nothing but rotating equipment. I mean, when you look at compressor farms and the fans and everything else, you're just talking about millions and millions of dollars of equipment and putting sensors on all of them and understanding in a way that we never had before. You might want to talk about that for a few seconds, but also I was wondering if there's any other areas comparable to that that you see as being particularly susceptible to predictive analytics approach.
Yeah, I mean, to hit on your first point, the amount of rotating equipment out there, the reason I think that predictive maintenance is has such a good value proposition in the short term is that there's so much rotating equipment out there, like you were saying, that are effectively unmonitored, and they can control really expensive parts of a line that if they go down, it represents a huge cost. So I think the value proposition is there, and companies are seeing that, and they're developing solutions rapidly to address it. Outside of rotating equipment, so I've done a report looking at packaging machinery in the past, and that's more heavily motion centric. So a lot of servo motors still rotating to an extent, but not the same rotating equipment that we discussed and what I was presenting. That's another area that's getting attention. So any sort of robotics application or motion application, people are starting to. It's difficult to do vibration analysis on servo applications because it's not as steady state as a motor. So they rely more heavily on on infrared or any sort of temperature reading. There's and robotics as well. There's other data points that you can gather that are really useful. I've heard it kind of seems simple, but the amount of safety stops that are deployed on a robot can be indicative of how much stress it's experienced in the past. The other thing that someone had mentioned is they're gathering any sort of information off the PLC of the path that a robot has taken over the last X amount of use cases or X amount of time. Again, can be used to trend how much that robot has been used and how much stress it's been under. So it's not limited to rotating equipment, but I think rotating equipment, in my opinion, represents sort of the lowest hanging opportunity for this technology at the moment.
Great. That's all the time we have for questions today. I want to thank Mike and Blake for sharing their time and expertise. And I'd also like to thank special thanks to Epicor for sponsoring today's event. And now that we're just about done, we'd like to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcast. Finally, on behalf of Plant Engineering and CFE Media, I'd like to thank you for attending. That includes our webcast, and we'll see you next time.